Introduction to support vector machines. Ever wondered how an algorithm can divide and conquer data, separating it into clear, distinct classes? Welcome to the world of support vector machines, or SVMs, a powerful, versatile algorithm that's been turning heads since the 1990s. SVMs are supervised learning models, which means they learn from provided data to make predictions or decisions without being explicitly programmed to perform the task. They are particularly adept at classification problems, although they can also be used for regression tasks. Now let's delve into the heart of SVMs and understand how they work. The main goal of an SVM is to find a hyperplane in an n-dimensional space that distinctly classifies data points into two categories. For simplicity, think of a hyperplane as a line that linearly separates and classifies a set of data. The algorithm works in a step-by-step manner. Firstly, it identifies the hyperplane with the maximum margin, which is the maximum distance between data points of two classes. The data points that are closest to the hyperplane are the support vectors. The hyperplane is chosen in such a way that the distance from it to the support vectors on either side is maximized. Sound simple? Well, it's a bit more complex when the data is not linearly separable. This is where the magic of SVM comes into play. The SVM uses a technique called the kernel trick. The kernel trick involves transforming the data into a higher dimension to make it linearly separable. Different kernel functions can be used depending on the nature of the data. However, SVMs are not all-powerful. They have their limitations. For instance, they tend to underperform when dealing with larger data sets because the training time happens to be cubic in the size of the data set. They also don't work well with lots and lots of noise. So when the classes are overlapping, you have to count independent evidence. In conclusion, SVMs are a powerful tool in the data scientist's arsenal. They are adept at handling smaller, complex data sets and shine in classification problems. Their ability to transform nonlinear data and find the optimal hyperplane for classification makes them a versatile and valuable algorithm to understand and utilize. So next time you're faced with a classification problem, why not consider an SVM? With the right data and the right kernel, it might just be the perfect tool for the job.